All right, Steven. I'm actually excited for this. Haven't had safety guy on in a while, and I really like trying to connect the field with safety. I try to help as much as I can, like whether it's engineering, safety, whatever. I try to like connect those dots because they don't always connect.
Yeah.
So it's good to have you on. Thanks for
Yeah.
coming.
No, I appreciate being here. It's a cool opportunity. So.
How did you get into the industry? Get into the trade?
So I initially went to school to be a technology teacher. I always liked, technology, woodworking, auto shop. Went to college, realized that probably wasn't the best option because technology teachers were getting cut when the budget didn't pass. So one of my friend's parents actually owned a line company, and I got to work as an internship in the summer as a safety professional. So that's kind of how I initially got into it. So I did that for a couple of years.
That's like college age.
That was college. Yep. So.
What was the turning? Why did you choose that? Like, what was interesting about it, I guess?
Well, I guess the safety side of it was when I went to school for tech, a lot of classes overlapped, and the college I went to had a strong safety program. So, that allowed me to transfer a lot of those credits over to the safety program. So that's
was like safety stuff like something that you were interested in at that time? Like, how did you get into that part?
Yeah, I guess it was more the construction aspect. It was a construction safety program. So, learning about, how things are built and things like that, the technology side of it. And obviously keeping people safe is definitely something that interested me. So.
I think this is cool because I often talk about like how there's a lack of tradespeople and we need to fill this massive void in America anyway, probably worldwide with tradespeople. But there's so many sides to the trades, not just swinging hammers and, climbing poles. There's actually like, infrastructure built around it, like safety departments and stuff that, need it just as much. So that's pretty cool too. What do you think the biggest differences are right now in safety culture with like the things that separate the field from the office? Like what are your butting head moments right now?
I think it's, we put a lot of expectations in place over the last, 5-10 years, and it's just trying to marry those up with the reality of the challenges of the work, right? We come up with rules, and work's done differently across the country. If you're doing distribution work in New Hampshire, you're gloving 34.5. You go out west, it's done with stick work. So as one company trying to set a policy of how work's performed across the board, that's challenging because work's done different, customer union by union, and there's more than one way to skin a cat, and trying to set one set of rules is a challenge. So that's I think probably one of the biggest things we run into. So.
How are you managing that?
Setting a baseline of minimum expectations, right, and then trying to adjust our policies that if we have a deviation from that, we have a process that we go through to try to address how that work's performed in that area. So it's something that's done with the safety, with the field supervision, and really that is driven by our ops people. So our op presidents within our company, they make the decisions of really saying that they're allowing work to be performed that way after it's been thoroughly vetted. So.
I was at the last president's meeting, and something that really stood out to me there was you're making, was the president's meeting? Maybe it was ISS. Anyway, the thing that stood out was that you guys are now working with utilities, like contractor being Quanta, and utilities to like make information more public when it comes to like incidences and stuff. I thought is that something that's like happening more now?
Yeah, I would say that, that initial, back in the day when something happened and everyone kind of circled the wagons and you didn't hear about it. At MJ, I feel like that's almost completely dissolved, at least from the management side. We're not worried about sharing an incident with Quanta and being completely transparent with what happened, or a customer for that matter. I think the capacity model and just that whole idea of failing safely has that drastically changed that interaction and really opened it up. I think there's still some barriers that exist, whether that's from the field up to management or from certain management up to our customer. But overall, I feel like that there's been a drastic change in my time in the industry. So,
what can linemen do better to interact with safety better, and then vice versa as well?
Yeah, I mean, I look back at the projects when I first started, and there were some challenging ones where I definitely butted head with the crews, and that was I think a lot from my inexperience in the industry and not knowing what was going on and being thrown into a position where I really wasn't confident or comfortable, so I didn't probably approach things properly. But then where was I successful too? And I had certain GFs and foremen that I'm friends with today because of our relationship on those jobs. They took me under their wing. They kind of showed me and they kind of said, yeah, come over here, take a look at this, and really, helped embed me into the project. And that was really helpful. I think that's probably the biggest thing. Everyone has strengths. Every safety person has different strengths. There's a lot of different type of safety people out there. Understand what their skills are and use them to your advantage, and help try to get those people as a member of your crew to function and support you. So
Try to build relationships.
yeah.
And that's like advice for both directions.
Definitely, yeah.
That's what safety people could do as well. Just try to build.
Yeah, and then I think from the safety persons, looking back, you're not out there to get people. You're not there to write people up. That should never be your objective. They know how much you care about them, and that you're doing it to try to keep them safe, keep the customer happy, keep operations happy. That's the intent of why you're there. So,
Someone I was just thinking about actually is Quanta's like, we're diversifying, I guess is a good word for it, right? Into like many different segmented industries and segments within those industries as well. How are you guys learning from that, and what can you pass on to people that aren't in that scenario?
Yeah, I think the one big one for us is probably horizontal directional drilling. I feel like that's one of those things that over the last couple of years has really blown up at MJ. It's we've taken on a lot of that work. We've tried to really surround ourselves with other opcos that do that work. So talking with companies like InfoSource or other companies that we have within this Quanta umbrella to understand that work a little better. A couple of years back, we started to get into some telecom work. We did the same thing with that. And that I think that's key, is to use the resources available, but also bring the field in. When we start to understand these work practices, we want to sometimes apply those rules and policies that we have for line work to these other things, and that's going to be a huge change to this new group of people. And we definitely have things that we can probably impart on that type of work, like horizontal directional drilling that we learned from the utility side, but there's a lot to be learned in both directions. So I think really kind of establishing these committees for that type of work to make sure that we're aligned.
Do you have any specific example of something that was done in one area and helped?
I think when we look at HDD work, we talk about hydrovac work a lot. We have this or even in HDD work, this exposure to step and touch potential with our horizontal directional drilling. I think there's the inherent possibility that when we're drilling, we can hit something underground. It's going to happen. I think we recognize the hazard and the potential hazard there. And, we talk about what the manufacturer of the drill rigs require for PPE. But there's some hesitancy, I think, in the field to really adopt some of those practices that we're trying to push on them. We're trying to learn about it too. So
what are some common misconceptions among linemen?
I don't know. I guess I think that the biggest one, which I think is starting to be weed out, is that the safety people are the safety cops. That's what we're here for. And I think that's
taken a while to phase out.
Yeah,
it sucks because it was that way for a long time. It was just gotcha stuff.
Yeah.
There's still a lot of safety people like that, but yeah, that's good.
Yeah.
So yeah, I'll move on from that. I'm not going to bring that one up. Sorry.
No.
Tell me about training. We were just talking about it a little bit. What are some of the advancements we're making in training? What are some things that, because again, Quanta is like one of the leaders in big believers in pushing training your professionals on whatever level. What are some things we're doing?
Yeah, I think about when I first started with MJ, and they actually did quite a bit to get us trained up at that point, but I think we've still made leaps and bounds. I think it was my third week here working for MJ, and I got sent down to Houston to do, train the trainer for rig sig training. And so I got trained the trainer on that, and then I basically got rolled out and said, all right, go train 60 linemen in this. And I really barely understood it myself as far as the calculations and that type of stuff. So kind of was just kind of thrown to the wolves back then. They tried to, get you up to speed, but now with this vetting program of, tier 1, tier 2, and tier 3 trainers, we're making sure that before we put a safety professional in front of a group of linemen, we know that they can teach this class because they've been vetted. They've been reviewed. And,
explain that a little bit more. Explain the tiers a little bit more.
yeah. So the idea is that, we have some classes, like tier 1 training would be just basic training you come on with, hazard communication, fall protection, what you would think of as safety orientation training when you come on. Tier 2 might be a little bit more advanced, where you have, trenching and excavation training, confined space training, things like that. And then when you get into tier 3, that's where you have like linemen like yourself, or people with experience that are able to teach on the transbank or the EPZ ground or helicopter work, things like that. So really kind of structure it out and make sure we got the right instructors in front of our people. So.
And this is like you're going across the organization with this type of training?
Yeah.
When does this come in?
I would say this first was introduced at with Quanta probably about 4 or 5 years ago now, like first started. And the way it was first introduced was that, the directive was that all safety people are going to go through this PTE course that's going to basically teach them how to communicate, how to get up in front of a group, how to develop a presentation, how to get an idea across. So, we've been really pushing that ever since. So.
How does it work with the safety department and the safety professionals? Like, are you paired with like other leadership? Are you mentored through, like, how does that growth for somebody coming in that wants to be in the safety professional world?
Yeah.
Like, I don't know how that works. How does it work?
Yeah, I guess it really depends on the company and the structure. I'll give an example of a couple folks that have worked for me. We had 2 individuals, Carson and Matt, that didn't have a safety background at all, but they were working for MJ Electric and they had a ton of potential. And we saw them, as great candidates for safety people. And what we did was we brought them in, and at that time, they understood the industry. Carson at the time came from a tool control background, so he understood all the tools and equipment that was involved. There are courses and things like that you can take. Specific to this industry is always a challenge. So what we tried to do was really just, help them understand what resources were available within Quanta and with MJ for training. And have them spend time with the field, understand the work tasks, understand how work's performed, and really, like I said earlier, get embedded with those.
What else makes like a good candidate?
Communication's a big one. It's something I guess I didn't realize when I first came to safety. I didn't realize I was going to be speaking. As much if that was told to me, I probably would have ran away. Yeah. But I think that's a huge factor. You got to be resilient. You got to be able to get up there and make sure you can interact with different personality types and be confident enough not to get dissuaded by that.
I get asked by kids all the time, early 20s, how do I get into the industry? How do I get into the trade? And they're always asking about like line work. So I've kind of given this formulaic answer, like do this, 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 and this, but like, what's that answer for a safety professional? It's like, hey, I'm really interested in safety. I want to get into safety in the electrical industry or whatever in industry. What do you tell them?
Yeah. I mean, I would say if you're, depending on which route you want to go, definitely, there's a lot of programs out there by schools and VOTECs that you can understand more about safety. I mean, anywhere in the country, it used to be.
Is there any better than others?
I went to Keene State, so I'm a little partial to that, but there are so many out there. Every state now has some type of a college with a safety program, and know what you want to get into. If you want to get into manufacturing, if you want to get into construction, they have different specialties. So, I mean, that helps if you have a general understanding of kind of.
How do you find that understanding?
Of
like what direction you'd want to go in?
I think it's what do you want to do? In our industry is unique because there's a lot of travel involved. So I think when you look at that construction, you're going to know that's inherent. You're going to be traveling, so be aware of that. General industry, you'll probably be more set in a factory setting or in a different type of environment. But I think that might be one thing to.
What other expectations should a person have getting into this industry?
That travel, I think, is a big one. That's something that is huge, right?
What are they looking at for travel?
It's going to be probably more than you want to know.
No, but this is good. Yeah, honestly, because I talked about this on the last couple episodes. I quoted Micro just said on Theo Vaughn's podcast a few weeks ago there's 650,000 open trades positions in America right now we can't fill right now because nobody even wants to go into that or knows about it or whatever. So for 650,000 like trade positions, there's probably just as many in each and every other supporting department within the trades as well, right? Including safety. So this is good for somebody that's listening and going, hey, like safety's my thing. I want to get into it. Like they have a passion for it, but it's good for them to know.
Yeah. And whether
expect to travel, expect this, expect that, right?
Whether safety or project management's the same thing. You're going to have the same, that's the same factors. So,
yeah. Let's talk about AI.
Yeah.
What's happening? Like Quanta's massive, obviously, 70,000 employees, 350-ish operating companies across different industries, just setting it up for people so they understand AI is massive. How are we tackling that within safety?
Yeah. That question was asked, I think like 2 years ago to me, like, are we using AI for safety yet? I'm like, at that time, I didn't even know what that meant, right? What does that mean? And I think now we're starting to see kind of trying to get that vision of what it could be. And even with that said, we don't know where it's going to be in 2 years, 3 years, 4 years. We've established some committees within Quanta and even, within the different opcos have committees to look at and start exploring AI in safety and other departments. And I think where we're heading with it at MJ is mainly looking at how can we actually use AI to not increase our dependency on technology, but to reduce the burden on our frontline workers and our supervision. I take full responsibility because when I started at MJ, our daily job briefing was one side piece of paper, and it was probably 12 or 14 font. It was a lot of white space to be filled out and written. Now we have a 2-page document that's probably size 7 font that would, if you truly went through it front to back, it takes a long time to complete. And it's not really conducive to a discussion.
Right.
And, you go out there with the crews and you ask them, hey, we were out in Wisconsin the other week and I asked, what do you think about the daily job briefing? And they said, this isn't for me, it's for you. And I think that's what really bothers me. I think a few years back, I was watching a crew in Connecticut do distribution work. And they had just finished one pole, and they were going to go one pole over. And, they went through the whole work task, everything they were going to be doing, start to finish, all the tools, equipment, and then they turned around and said, all right, let's go do the job briefing. To me, that was like, well, you guys just did the job briefing, but it's looked at as something else. It's not part of the work, which is really what it was always intended to be. It was that project planning. And at some point it moved from a discussion to a document. And we're looking at how can I undo what I did to MJ with that 2-page document over the last 10 years and turn it back to a conversation. And we have some tools right now that basically allow us to take a conversation just like you and I are having. And we've learned so much. Don't get me wrong. Everything on that piece of paper is written in blood. We've had incidents, we've had events. There's a reason for everything on there. But how can we take this conversation and autofill, because people take that the wrong way.
Yeah, like it just checked all the boxes.
It's going to populate it based on our discussion.
Yeah.
And it's going to take that administrative burden away from our employees in the front line having to fill out that paperwork. And then how can we also apply that to other things that they're doing? There's probably half a dozen other forms they're supposed to be filling out. How can that same conversation capture other things, whether it's dig safe verifications or other things like that? So
that's super interesting, actually. It's not like you didn't talk about it. Like you had the discussion, you had the job brief. It's just able to capture that for you and essentially check that box so you don't have to go back over it again.
Yeah.
I wonder how much of that, like you just said, I wonder how much of that happens, in the bucket. Yeah. That's so just in the bucket as you're normally working, you're talking about, the job that you're doing, and none of that gets recorded. Yeah. So that'd be interesting if, you could capture that stuff too.
Oh, I mean, we talk about that all the time because, on paper, if you have a change in your work scope or a hazard, you're supposed to stop and do a completely new job briefing.
Yeah.
In reality, you're up in the bucket. You're not going to come down.
Yeah.
You're going to have a discussion with the other guy in the air, and you're going to come up with a solution, and you're going to move forward, right? So how do you capture that and address for that too? It's.
Is there some resistance to this?
I think initially when you say, "Oh, we want to record your job briefing," there's absolutely resistance. Then when you sit down and have a conversation, like tell them what we just said, guys like, "Oh, that sounds kind of cool. I'll try that." And we're demoing it right now. We're kind of doing a soft rollout, but overall, there seems to, once people understand the intent of it and why we're doing it and how it'll help them, I think I think it'll kind of work itself out. We rolled out digital job briefings on iPads a couple of years ago, and I think we saw the same type of resistance when we first rolled that out. But that I think was a step forward, but it wasn't as far as this is going to be. So
I was talking about this with one of the guys this week that I had on the show. So we were just like exploring, like, oh, what could AI potentially do if you just, I don't know, it starts progressing. And I was talking about like full on, I'll probably lose a bunch of guys right here, right now, but whatever. It's fun to like go through these mental exercises. Like, what could it do? Outfit the bucket with cameras kind of everywhere. And, the ability to listen. There's like full ability to capture what's going on in the air, right? Yeah. But then to use it almost as like a coach, like say you had like your lineman in the air, you almost got like an earpiece in or something like that. And you can work with AI, like almost like I use a Star Wars reference, like almost like it's R2-D2, like R2-D2 only made Luke fly better. Right? And that's the same thing. It almost makes us fly better. Like if you're coming up against a hairy situation, a bank, I don't know, you need some coaching through what you're doing. It can help you or warn you that A phase is pretty close to your left shoulder, second point. I don't know, just things like that. I thought that would be kind of cool, maybe potentially, but then guys probably lose them because they're like, fuck that, I don't want to.
The safety guy on their shoulder.
That sounds horrible. I want to cheat. But I don't know. What other things, that's pie in the sky. What other things are like happening right now?
So, I mean, the capacity model has been, I would say, one of the biggest initiatives we've had over the last 5-6 years now. And for us, the introduction of that, talk about what's changed in the industry. I think opening up and looking at, us not attacking crews when they have an incident, and I hope our crews feel this way, but there's been a drastic change in how we react to incidents. We're not looking to blame. We're not looking to punish. We're looking to learn from these events. We want to have sticky successes when we fail, right? We want to fail safely. But when we have a potential, it's not looked down on as you did something wrong. We're looking at, all right, what can we do better next time? And that's my mentality. That I think our operations leadership has adopted that mentality. I still think there's work to do for the crews to understand that that's truly what we believe. So
what's the turnaround look like on like an event happening or potentially happening, and then like some sort of thing being put in place as a result of that, like some sort of action being taken to make things better? What's that turnaround look like?
I think it depends. Sometimes that the quicker it is, it's going to be a drastic, immediate response, and that's not what we're looking for. So I think what we're looking at is trends. So we don't want to take one incident by itself and have an overarching, this has to change for every task. We want to understand, how is that unique to that just one event, or is it a systemic problem we have for that task across the country? So sometimes there's some time. Trying to put examples to it. So one of them was the lockout tag out for horizontal directional drills. There was a lot of attention on that for across Quanta last year because we had a fatality in the Quanta company with a Quanta company, and we had a near miss at MJ Electric where an employee got his leg basically sucked up into a piece of pipe, and it was just by chance that they had to change out the drill and the drill stem, and it stopped at his knee. So, we look at these events are happening. We don't want to make an immediate reaction or change just based on one event. We put together a learning team. So part of the capacity model, bring guys from the field in, let's talk about this issue and try to learn from it and putting meaningful change. The other one we had was pole tongs. We didn't just have one incident with a pole tong where it got lost and hurt someone. We had a rash of them. Yeah. And it was a matter of time before it led to an even more serious event. So again, we put together learning teams. We looked at, well, you know what? When we have poles dropped off in our yards, we have no communication with them. They just kind of drop them off wherever they want. And sometimes a phone call and labeling the bunks and separating them out by size, that goes a long way in not having to move 10 poles to get the one you want. So a little bit of coordination, setting up some best practices, and trying to make that uniform across all of our regions. I think that's been another area where we're trying to make impactful
That sounds like such a simple thing, but it's so true. It's like you set it up right in the beginning. You don't have to touch the pole now and potentially have. Yeah, it's so cool. Let's move on to the simulator.
Yeah.
How did this thing come about?
So in 2017, we had a fatality at MJ Electric. We were working outside of Townsend, Delaware, and we had a 230 kV line rebuild. There was a parallel 230 kV line right next to it, about 100 feet off, running parallel with the line we were working. The line we were working on was de-energized. We just pulled in structure 1 to 17 on the north end of the project. Structure 1 was at a substation, obviously, and the structure 17 was a dead-end hard angle. And the crews had kind of finished up the wire pull. The hard work was done. They were in the process of training the fiber down the pole, so probably what you kind of consider, lower risk work. And they had trained the fiber about halfway down the pole. They were right around the lower phase, and they ran into an issue. And the issue was going south. That line was grounded phase to ground. So from the structure to the phase for those 3 phases on the static. Going back north to structure 1, it was grounded in a daisy chain configuration. So phase ground to phase, phase to phase as it goes up. That lower phase going south was the ground point. It wasn't on a structure ground or a vang. It was on the fiber bracket that they needed to get to. There were 2 men in the bucket. One apprentice was on the ground. The one guy in the bucket turned around to pick up the material for the fiber bracket, and when he turned around, the other employee had the ground end in his hand. We don't know if it fell off, if it broke off, if he took it off and tried to slide it. We don't know. The other employee in the bucket kicked the ground out of the employee's hand, and they immediately brought him to the ground and did everything they could to try to revive him. We had an AED on site. The apprentice on the ground was actually a career EMT before he joined the apprenticeship. So the type of person you would want to be there, and despite their best efforts, they weren't able to revive him. So that was I would say the triggering event. From that, obviously OSHA and customer investigation pursued, trying to understand what happened and trying to really get into the event. We had requested that we make a scale model of the site to be able to show OSHA, hey, this is what happened, and try to explain it, because it's kind of a hard thing to be able to get up and explain something exactly how everything moves around. And at that time, I had always been into 3D modeling. I made us our grounding books and things like that, and so I always tried to use that as a helpful tool for our employees. But I got a 3D printer for like $200 or $300 a couple months earlier, and I just started messing around and said, I think I can make that scale model pretty easily on there. So started out as just a model of that structure and that event. And then it never really went anywhere from there, used outside of that. It sat around in the office, and it was just a reminder of the event. And then I realized one day, I was like, I could probably, looking at the AB Chance simulator and other simulators out there, like, I think I can do a better job and make this a little better. And I, one thing led to another, and I opened my mouth and told my boss I thought I could do that. And then I was like, all right, where is it? And we started working on it, and we had, some early prototypes that I had used at training, which got awesome feedback from the crews, but they were nowhere near what it needed to be to really, get it out there. And then it kind of went away for a little bit. We started looking at like VR as being an alternative to that. I guess I was like, this is going to take over. We're going to be able to go that route. And that didn't really pan out because the guys don't like putting the headsets on. Trying to get 5-10 linemen to put a headset on in the room. No one trusts each other. And so that didn't work out. So
I could see that. Went
back to the simulator, and I was like, I got to get this done. It was halfway done. So a couple revisions later, we rolled out, and just bring it to trainings. And a huge thanks to some key people that helped me do it, and gave me some feedback. Derek Martin was general foreman for us at MJ Electric, and he works for local 104 now as their safety professional. And a lineman, awesome, one of those guys that kind of took me under his wing when I was young, and said, Steve, you got to push this forward. This is a great tool, and gave me the support to really help pushing it forward. And made tweaks, got feedback every time I brought it in front of a group of linemen. They said, oh, it's cool, but you should have a guy wire here. You should, add this in. You should show this. And, we added wire pulls, we added cranes, and we kept kind of building it. So reluctant every time I put it in front of a lineman, they want something else on it. So, but
typical.
Yeah. But overall, it's one of those tools. I watch guys like, you have these, these guys like James McGowan and James Mosier, who are just like incredible trainers. And they have so much experience and stories. And then, we have our EPZ grounding trailers, which are awesome. But you're only going to get to watch James McGowan or James Mosier or EPZ grounding once a year if you're lucky.
Yeah.
What do we do for all the other people coming into our organization? And this was kind of that option where I can take a safety professional, and in a matter of a couple hours, I can get them trained up on how to present that in a training. Mm-hmm. So we can use that as a tool to make sure we're not just training off of PowerPoint, right? And as a safety professional, it's like kind of like a crutch, right? You're not just reading off slides, and you can show someone, you can move stuff around, you can actually see how it works. And as we started to develop it, all the scenarios, there's no smoke and mirrors. It's not like there's computer coding where when you hook it up, it's just simple, DC circuits with resistors in it that just kind of represent what we're worried about happening.
Talk about that process of prototyping and figuring that part out.
Yeah, that was probably definitely the biggest learning experience in my life. I have no electrical background from electrical engineering. Me and my dad rewired boats and stuff like that when I was a kid, and fixed up some stuff around the house. But I didn't. There's nothing I really feel like I had a formal education in. So that was a big dive into understanding, that, and kind of tinkering around with that and understanding, when you put voltage through a resistor, what happens, and, series and combination circuits, and actually building them out physically on circuit boards, as we wanted to make this thing, real. And in doing that, just kind of a lot of mistakes, a lot of messing around, and got it to the point where, I had it working and using different microcontrollers and things like that to help me along the way. I mentioned AI in the last year or two. I mean, that has helped me get this thing as a wireless Bluetooth device, and really just brought it along. But there was a lot of learning, whether it was learning how to make a circuit board or 3D graphic design, 3D modeling, production. So
we'll walk through it in a minute, but how many different scenarios can you create with this, or is it kind of like sky's the limit?
Yeah, I mean, there are definitely limitations. It's a DC circuit, it's not an AC circuit. But even with that, we can simulate some, potentially some induction, and that we don't have that yet. But there's probably about 15 different base scenarios that we have right now, and there's probably another 5-10 on the burner that we're looking to do. So
has there been when you teach with it and you present in front of a bunch of linemen, has there been some eye-opening, I didn't understand how that works? Yeah.
Yeah, I think the EPZ mats has been a big one for our EPZ mat setup. We asked the guys, we want every edge of those EPZ mats bonded together. And, we had some crews that would set them up in a big S pattern just to, everything's connected, but all those different resistance points, add up. I think that's been a huge eye opener for our crews. But I haven't, every time we've done training, guys come up and they want to play around with it. So it's been what's made it continue to get better, and me wanting to pursue it is seeing that, that reaction to it. So
was it kind of neat getting the innovation award?
Oh yeah, that was super cool. The whole experience, and you look at all the innovations that they had there. Whether it's not even as something like that, that socket adapter. We had a socket adapter like that break up 35 feet in the air, come down, go through a guy's hard hat, and cause a serious injury. You look at the fall protection around a drill hole. We've had guys fall into drilled holes. Significant injuries there. Every single one we've had, the other one was the bat wing for the boom. Every one of those, we've had some type of sticky event around all those. So just to look at like what's different today with the capacity model, every single one of those innovations was looking at how do we prevent these injuries happening again in the future. So for me, that whole experience and really getting to see it up front was awesome.
Do you have something that you're working on like as the next thing?
So yeah, the next thing we're playing around with, which we're actually almost there, is rigging and weights and forces. So to be
in what way? Like the same sort of thing, like a simulator?
Same sort of thing. So miniature, think of like load cells, like dynos. Cool. So like miniature dynos that you can put on structures and pull weights and forces, or you can, show angles when you're rigging and stuff like that, and what happens when you add a block here and that. So
or a little bit of bisect.
Yes, exactly. Yeah. So that's still working around with it, but
that's super cool.
I got the basic units all working, so it's gonna kind of see what happens as we start to hook more.
That really helped the learning curve, especially from like a distro lineman to jumping into a transmission role for the first time, just because that's something that a lot of distro guys just don't quite realize until they get into transmissions. What kind of weights and forces you're actually dealing with.
Yeah.
Cool. Well, let's walk through this thing.
Yeah, sounds good.
So we got everything into one Pelican, or so in this case it's a SBK box, and I got everything wired in so we can travel with it.
And you made all the boards and everything.
Yeah.
Everything from scratch.
Yeah, well, everything was prototyped, and then we were able to get everything mass produced, and kind of helps out, saves a lot of time from soldering and stuff like that.
What did you like? What was like point one like that you started with? Like you started like, did you draw a sketch or something?
Yeah.
Come up with a computer design first? Or?
Yeah. So yeah, it was probably just I have a bunch of sketches that I started, and like the way kind of power going up the main pole and kind of building out from there. Step potential was just so. This was actually like probably one of the later ones, but think about like a ground grid and a substation. So these are just resistors between each of these points. So you just set up like a ground grid, basically. Cool. So it shows those rings. If you introduce current into there or voltage in there, it's going to radiate out from any one of those points. So this is where the power comes in. It's a USB-C. So that goes into a voltage divider. So it basically divides that 5 volts DC into millivolts, 300 millivolts, 600 millivolts, 900. And it does that 8 times. And then that comes out. Let me do the background over there. So then what happens is that comes out on those 8 pins there. So then you have 3 phases on either side and the 2 statics. So every one of them is at a slightly different potential. And then these are all eventually referenced back to ground, but they have resistors through all of them. So you can see this one. And then those are just the 8 pins there. So initially there was a whole bunch of wires and stuff on it, but this just made it a lot easier.
Slick.
And it's done. So on this,
I love that you made it like a decent size too. It's not this little fragile.
It was a balance between being able to travel with it, right?
Yeah.
And then,
well, because some of them I've seen, they're like this big, and you're like, oh, this is cool. But it seems more like a toy than this. Seems legit.
That was a big part of it, is getting it to the point where you can put it together, take it apart, and it doesn't break. That was definitely a challenge.
So cool, like you had to make everything or find all the little
there's a lot of different parts and pieces.
And, yeah, like I'm just looking at all the little things, like just even these little connectors. And
so what works best, it was kind of a lot of trial and error.
A lot of like late night flipping through Amazon trying to find random shit.
Honestly, I would say almost every single thing on here was bought on Amazon. Yeah. So these just give the structure a reference back to ground.
Gotcha.
In between the structure, there are little there's actually, have you ever seen like when you cut foam, you use resistance wire? They put like voltage and they can cut foam. So that's resistance wire, because there's a little bit of resistance in the structure. These are obviously made of plastic.
Gotcha.
So that kind of gives it, I think it's it's like maybe a half an ohm between these points. Might be a little higher than what it actually is in real life. I think we've tested a couple. It was like, 0.2 ohms, depending on the structure. But it might give a little exaggeration. But aside from that, that's, the way I start out is just kind of explaining, kind of go through the historical approach to grounding, and start by saying, like, I'm not suggesting that that you ground this way, but just as a discussion, we could say, all right, if we had a ground here, a ground here, or ground here, like, would you agree that that circuit is grounded? Like,
Yep.
All three phases are grounded, so you can say that. But then we can say, do we have an issue here? If I was to be a lineman and I was to make face-to-face contact for whatever reason, like, we have an issue, and you have 4,000 volts. Every line is grounded, but we still have voltage regardless of the fact it's grounding. So number one, grounding does not, make energy disappear, right? Number two, just because two phases are grounded doesn't necessarily mean they're at the same potential. So we ask, how can we make this a little bit better? I have to do this in the right order, so I was to remove the ground in, I get yelled at by the line.
Yeah.
but a little bit better would be, all right, well, let's bring these all back to the same potential. And again, would we really have 120-foot ground going to ground? Probably not, but at least this would probably solve this issue, right? Now, at least we brought these phases to the same potential. So in this case, our issue was resistance
Separation.
through the ground,
Yeah.
right? And again, not really practical, but so now we can go over to this structure here and be like, all right, great. I'm grounded. If I was to be working on this structure, maybe making contact with the arm and touch that phase, am I protected?
Negative.
No, right? Because again, you have this resistance
Distance between that.
between that and that. So what would you want to see? You'd want to see, from the structure to the conductor being worked, and that's going to drop that down to 0. All right. Now, in this case, what happens here is this is going to show a little bit of voltage, but let's take these off. Okay. Again, from this structure to this structure, we're going to have an issue, and we have two options. You could do a phase to ground configuration, or you can do a phase to phase as you go up. And here you'll see you'll be in pretty good shape. As you go up. So I can work on the next phase up. Oh, I lost that. You can see it went up a little bit, so you see a little bit of voltage, and that resistance is what you have from this pin back down to this.
Wow.
Plus, you're working your way back up. There is going to be a little bit of resistance through each of your ground ends. So we're not saying you can't do this. That's absolutely an acceptable method to ground this way. But just be aware, as you have more grounds in that chain, there's more resistance points, and it might be why you're getting bit during the day. It's a possibility, but so. Then as you go all the way up to the top again.
Yeah.
So now some people will be like, all right, well, but our static is actually probably bonded at the top of the structure. So if they call you on that, you can say, yeah, that's true. And you know what, on your top phase, that'll bring you back. It might give you a little bit of, so you might see a little bit here on your lower ones. So, all right, so from there we say, all right, that's a good single point ground. You can work on that anywhere on that structure to any one of those phases, and you're not gonna have an issue. What happens when you go over to this guy here?
Got the distance now.
Yeah. So now, again, your EPZ is all the way separated by this. So you're going to want to have this guy here to make your EPZ from your work area. Now, I'm not suggesting, I always say, I'm not suggesting you do this, but if you're one span away and you do this and you hook up here, you might get away with that. 15 volts is, 50 volts is our threshold for OSHA, right? Because that's what's going to break your skin's resistance and go, potentially go through you. So that's survivable. I'm never going to suggest that you do this, but even as you work your way up the pole, 20, and it'll get higher, it's still going to be technically within the acceptable limit. So you might get away with that working on this structure here. But that's why we throw in these resistors for line loss. So now take that same scenario, right? And let's make up these jumpers. So we go through the structure here.
Gotcha. You know, you've got your...
And let's try that same exact thing over here and see if it works. So now, obviously from here to here, I should be seeing a hazardous voltage.
Yeah.
So that's, all right, so let me put up my ground. So now I have my single point. Phase to ground here. I mean, I can test it here. I know there's gonna be nothing because I just have that connection, right? So I'm good there. Mm-hmm. So this same scenario over here, I was getting 15 volts, 20 volts. Same scenario. I'm at 200 volts. And see, I lost this one here, it jumped up.
225.
225. Next one up.
315.
315. All right, so let's say we even do have our static bond, right? We have our number 4 static bond. Struggling. So put a little higher. I'm gonna have to go to the outside phase here because that's where that one is. All right. So even with that bond, it's gonna lower it, but it's still 115. This one here, 115. So that truly you have to have a bond to each one of those. So that shows this resistor in here is not a huge resistor. I think it's a 20 or 30 ohm resistor.
That's enough though.
Now, that's a lot of resistance in a line, yeah. But you know, we don't always necessarily have a solid conductor. You have splices, you have hot spots, you have grounds, you have things up sometimes between you and that source. So it's just kind of shows the importance of that.
Crazy. That was neat to see. What scenarios do you demonstrate that you've seen like guys get in trouble? Like incident scenarios, do you simulate those?
Yeah, well, I like to do that from this one. I actually move over and we do the one from the event.
Okay.
Because the one in the event was basically this setup here, where on this side you had, this is actually almost an identical to structure 17. So this pole was modeled after the one from the event.
Wow.
And then on this side here,
now this is how they had it set up?
this is how they had it set up, yeah. And then going this way, this would have been structure 1, you know, or the 17 structures that way. This way, we did have grounds on this line. But again, we don't know for what reason, but when they got to this point here, this ground ended up in the employee's hand. This was an AH-125 bucket, yeah. metal basket. We don't know if the OPGW was contacting the basket or if the basket was up against the pole. But either way, that was at the same potential basically as the pole, right? Oh, I just flipped it here. This basket was at, you know, the same potential as the pole. So when this employee had one ground in his hand and another on the basket, he had that, you know, that voltage. I speculate, and I just, you know, if he thought, we don't know. Did he try to, there was something within reach that he could have slid it to there. There definitely was another bracket that he might have been trying to slide it. Or did he look at this side of the structure and see everything daisy chained up and think he was connected coming back down this side? You know what I mean? Yeah. I don't know. We don't know really what happened there on that side of it. But
so the second guy was just turned around doing something?
Yeah, he was getting the material for the fiber bushing, so.
Damn.
So again, there are other, you know, events. The EPZ one, I think, is I'll show that in a minute, but we can show events on there. But the other thing we really look at is the step potential out from there now. So if this is our grounded structure, what happens when we have a fault, right? If this line is put back into service, let's say.
Yep.
So this first one is almost nothing, right?
Good there, yeah.
But as we take this first step, 5,000.
It's already.
So 6,000 volts, roughly. So it's going to drop in half roughly for every step we take away from there.
It's wild. That's still more than enough.
Yeah.
So cool.
And then for our OPGW, we do show this as well. This was something that I think we need to be cognizant of. In this case, let me pull these guys off. I always get nailed and I'm like, took the ground end off first.
They're just waiting to catch you on
yeah.
something dumb. Sit in the back and laugh.
So on the OPGW side, we kind of have the opposite where, let's say our OPGW is going to be bonded at the top of the structure here. So as we're handling the OPGW, at the base of the structure, we're going to have a little bit. So again, that's that resistance down the structure. But if we're handling OPGW, the further we get away from that point, it actually is going to go up the further we're away. So it's something, that until this investigation and looking into it, recognized as a hazard.
Yeah.
It's a factor at least we need to be aware of, right? When we're coiling up that wire, if you want to, not necessarily say you need a full EPZ, but whether you're wearing class 2 gloves or something like that, just to be aware of it. So
Interesting.
So
Just makes you think how much potential stuff has happened out there.
well,
Just because,
you're wearing EH rated safety boots, right? They're $150, $200 pair of boots. They're tested. The ASTM standard, I think, is 13,000 or 15,000 volts. So I think they probably have exposure all day long, but we have enough resistance where we're not having incidents. So
100%. But it only takes kneeling down or something instead of, bumping something.
Yeah. So the other one, I think that we get a lot of kind of eye openers is this one here, is the EPZ side of it. I may need to hit reset because that cycles through 1,000 times and then it stops. So our EPZ setup, again, this is what we want our straps to look like, at least one on every adjoining edge. In reality, what we see in the field once in a while, I'm not saying all the time, but guys go, all right, well, I can hook up these here. All my mats are connected together. So everything's connected.
Yep.
I can do this.
Oh yeah, I got it.
So that's, we've gone out to the field and we've seen mats that were 5 by 10, and they said in an M shape, and they said everything's connected. We actually took a multimeter and we had about 500 ohms from end of resistance between them. So, you definitely, it's there. We say, well, we want our equipment to be grounded, right? So our equipment is grounded. Our equipment is also, in this case, bonded back to the mat, so that's good. We also want to see a running ground, right? So again, there we go. Running ground on the line. And then say we want to have at our breakover, you have a grounding block. Okay, so we have that. So in general, we're looking pretty good. If I was to work and get on and off the equipment, and I was standing on this line here to here, I shouldn't have much of an issue. But in reality, like we were talking about before, you might have something in the ground, whether it's an anchor holding down your piece of equipment, some other source to ground in there. So our mats sometimes have bolts and stuff like that. So 5,000 ohms, it might be a lot less than that. So that represents this. In this case here, what we always want to do is make sure that this ground is as close to the point of contact that we're touching. So your bond back from your equipment that you're getting on should be close to that access point where you're getting on and off.
Gotcha.
If you have one bad ground inside that, so let's just take this one here, let's take this one, this 50 ohm ground. Even if you have one bad one, by making sure your ground on your access point, you're in good shape. If we move this bond back over here.
You're right there.
So now you're 380, because that's, you have 1 weak link in your chain.
Yeah.
So again, by simply making sure that we have all of our edges bonded together,
You're back.
we don't have to worry about that 1 weak link. So that's why we say we want to have all of them together. So there's probably a couple other little scenarios, but that's like kind of the main ones that we run through. So
Thank you.
yeah.
That's awesome.
This content is completely free. All right. The only thing I'm asking you for is to hit that subscribe button. And I know it's cheesy. I know it's corny. I know every YouTuber asks you to hit that button and you're probably sick and tired of it. But if you like the show and you want to see the show grow, this is the way I prove to the people in charge that it's worth investing in. So it's pretty simple and it's the price you can pay for me. It's no money. It's just a subscribe. Please hit the subscribe and I appreciate the heck out of you for it.